Okay, so in this class we're going to look at the next group of hydrocarbons that we have on our course, and they are the alkenes. Now, as you already know, the alkenes, E-N-E-S, that tells us that there is a double bond somewhere in our chain. And we have to remember, for our course, we're only going to restrict ourselves to chains that only contain one double bond. So there are other alkenes out there that have two double bonds, they're dienes and trienes, but we're not going to worry about them in this course. We're going to stick with chains that only have one particular double bond on that chain. And then we're going to look at the first member of this particular homologous series. We're going to look at ethene, remembering that there can't be methane, and I just want you to think about why there cannot be methane. The first member is ethene, and there's a chemical reaction we have to take into the lab and do and create ethene, which obviously at this stage we can't do, but if we return before the end of the year we will do. I have a video of it here, and I also have an explanation on the slides. So let's take a look at them. The alkenes, first of all, it's a homologous series. Now please remember what a homologous series is. Homologous series is one of the longest definitions that we have on our course. A homologous series is a group of hydrocarbons with similar chemical bonding. So in other words, they all contain single bonds between their carbons, or double bonds, or double bond is somewhere present between their carbons, or a triple bond. So a homologous series is a group of compounds with the same chemical bonding, with similar chemical properties, where successive members in this series differ by CH2, and where there is a set ratio between their carbons and the hydrogens. Now, the set ratio for the alkenes, we'll see in a moment, is CnH2n. So in other words, in all alkenes, there is twice the amount of hydrogen to carbon in that particular molecule. They are unsaturated molecules. Now, this is a new word. You haven't met this before, but if you go back to your alkanes, the alkanes were a group of compounds of singly bonded carbons where the rest of the bonds were taken up by hydrogens or by a branch or by some other molecule. But to be unsaturated means that there is more space. I want you to even just think in terms of water. If you go out and you get saturated by rain, what does it mean? It means that you simply can't hold any more water. You're wet right through. But unsaturated means that there is the possibility of being able to hold more. And we'll talk more about that later on. The reason why they're unsaturated is because of this C double bond C. Don't forget, in the double bond there are 4 electrons. Now, it's not necessary to have 4 electrons to keep 2 carbons together. We can do with 2, thank you very much, as we saw with the alkanes. So therefore there is 2 electrons up here that could be utilized in order to add more hydrogen across these 2 carbons, or to add 2 bromines, as we'll see later on, or maybe to add 2 chlorines, or whatever needs to be added on around that double bond. But just keep in mind, the presence of a double bond is 4 electrons. 4 electrons not necessary to keep 2 carbons together. 2 is plenty. So therefore this bond here could open up, and the 2 electrons then involved could dedicate themselves to bonding with some other atoms. So that's what unsaturated means, the ability to hold more on the chain. All names end in E-N-E. Now that's the trademark. So just the same way as your trademark is probably your surname, the trademark here for these molecules in this homologous series is E-N-E. And general formula, as we saw already, is CnH2n, which means there's twice the amount of hydrogen to carbon. So how do we name them? Well, you remember all the rules we had for the alkanes? The same rules apply. There's just one extra thing we've got to be mindful of, and that is the position of the double bond. Now, this varies from textbook to textbook, and if we were in the States, they would do it a certain way. Over here, we do it a certain way. They're slightly different ways, but they mean exactly the same thing. But the presence of the double bond is all important. Not only that it's there, but we've got to number the carbon on which the double bond begins. So that's extremely important. When naming them, we must make references already to the lowest possible number that holds that double bond. All names will end, as we said already, in E-N-E, and the branches are named in the same way as before. And I hope you all remember that. A branch with 1 carbon, what does that give me? Methyl. So all branches are -YL. So methyl, ethyl, propyl, etc. Okay, so name the following molecule. So here I present you with this molecule here. How would I name this thing? Well, first of all, what do I notice? I notice the characteristic presence of a double bond. So straight away, that is an E-N-E. Now, what about it? Well, first of all, 1, 2, 3, 4. There are 4 carbons in the longest chain, meth, eth, prop, bute. so it's butene. Now, let's take a look and see, first of all, where is the double bond? Well, 1, 2, it's after the second carbon going this way. It's also after the second carbon going this way, so therefore it's but-2-ene. There is another way to name this. You could also call it 2-butene. I'm not too pushed on what way you use. The book uses this way. There's other systems out there that use this way, but please know they are the same. I don't mind what way you use it, as long as you understand exactly the naming process involved. So but-2-ene or 2-butene. Remember, what does it stand for? Presence of a double bond within a chain of 4 carbons after the second carbon. That's what the name means. And the same thing here. 4 carbons, there's a double bond present after the second carbon. So there it is. Longest chain, 4, but, double bond present after carbon number 2, 2-ene, and the name of the molecule therefore is but-2-ene, or as I said already, 2-butene, whatever you want to use yourself. What about this molecule? Take a look at it, see if you can do it in your heads before I give you the answer. Pause if you want to pause the video and try and work it out yourselves. Longest chain, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Do you notice that the chain I take has to contain the double bond? It must contain the double bond. So the longest chain here is 5. So this is pent. Double bond present, ene. Now where is it? 1, 2. It's after the second carbon going this way. 1, 2, 3. Or after the third carbon going this way. So we always give the lowest possible number. So therefore this is pent-2-ene. But you also notice something? If this happens to be the longest chain, we've got a branch, and the branch contains 1 carbon, so that is methyl. And where is it? It's also on the second carbon. So in this case we have 2-methyl pent-2-ene, or another way to say that, 2-methyl 2-pentene. It's up to yourselves. I don't mind what way you name it, but that's the way in which we do it. So you look at the longest chain, mark it off if you have to, and then see what is attached as a branch onto that particular chain. So again, longest chain is 5, the double bond is after the second carbon, so it's a 2-ene. Methyl group is also on the second carbon, so it's 2-methyl. Put them all together, 2-methyl pent-2-ene. So when asked to name an alkene, the molecules may be given in this format. Now there's another way, and you're going to see this in the workbook questions that I give you in a few moments. They might ask you to name something like that. Okay, now what you notice here is brackets. I thought brackets were only for algebra. No, brackets are for chemistry as well. But what does it mean? Well, first of all, it means that there is 1, 2, 3, 4 carbons in the longest chain. So what's this thing here? This thing here is a branch. And it's a branch that happens to be after this carbon. So it's stuck to this carbon. So therefore, when you've got a branch in brackets, that branch is directly attached to the carbon immediately before it. So let's see if I try to draw this thing. CH3, CH2, now C, with what? With a C2H5, so 2 carbons up this way here, followed by a double bond to a CH2. So there you have it, there's the molecule, that's what it looks like. Okay, so what is this molecule? Well, 1, 2, 3, 4, 5. So you could go that way. What have I done? I've missed a double bond, so I can't take 5 as the longest chain, even though you would be tempted to. The longest chain must contain the double bond. So 1, 2, 3, 4. 1, 2, 3, 4. So the longest chain containing the double bond is 4. MEP. This is but. Double bond, where is it? After carbon number 1 coming in from the left, or after carbon number 3 coming in from the right. So it's a but-1-ene. And what do I notice? I also notice that on the second carbon there is a branch with 2 carbons. So that happens to be an ethyl group. And because it's on the second carbon, it's a 2-ethyl but-1-ene. Or if you want to put it down as 2-ethyl 1-butene, that's perfectly fine by me. But either way, that's exactly how it works. Let me get rid of all that. So in this case, the C2H5, as we told you already in brackets, is a branch, and it's on the carbon immediately before it. So that there is on that carbon. Just keep that in mind. It's always on the carbon immediately before it. Sometimes it helps to draw these things out. Now the nearest molecule I could get by using the computer is this one here. But you notice that you have 1, 2, 3, 4, 1, 2, 3, 4. So I just take the longest chain there. The longest chain there would be this one, containing the double bond. Okay, MEPB. So it's butene, it's but1ene, and on the second carbon I have an ethyl group. So it's exactly the same thing. But that's what the molecule looks like in terms of the previous nomenclature, this one here, where we're given it in a straight line. So let's have a look at these. Name each compound. So I want you to pause now, try these yourselves, then unpause and come back for the answer. Okay, so now you have the answers to these two in front of you. Let's take a look and see what we have. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 looks as if it's the longest chain, so therefore it's going to be a pent. Double bond is present, so it's going to be an ene. Where is it? Well, 1, 2. It's after the second carbon coming in from the left. 1, 2, 3. 1, 2, 3. Or it's after the third carbon coming in from the right. So therefore we've got to give the lowest number. So this is a pent 2ene. So therefore we're coming this way. 1, 2, 3, 4, 5. Let's take that as the longest chain. What else do we notice? That's carbon number 2, carbon number 3, carbon number 4. So on the fourth carbon there is a branch, methyl. So this is 4-methyl pent 2-ene. Okay, this one here, 1, 2, 3, 4. 1, 2, 3, 4. So the longest chain is 4, MEPB. That's butane, we'll put but down first. Double bond will give me butene. And where is it? It's after the first carbon going this way, or 1, 2, 3, it's after the third carbon going this way. No, give it the shortest number, smallest number, 1. So therefore let's take this, 1, 2, 3, 4. Let's just take that as our longest chain. What do you notice? 1, 2, after the second carbon there's a branch, and the branch contains 2 carbons. That's an ethyl branch, and that's on the second carbon, so it's 2-ethyl but1ene, or as we said already, 2-ethyl 1-butene. Okay, good. Next one. Name each of these compounds. Again, pause, give me the answers and come back. Okay, so now that you have the answers, let's take a look at this one. 1, 2, 3, 4, 5, 6, 7, 8. So this is most definitely oct. Double bond, ene. Where is it? Well, 1, 2, 3, 4, 5, 6. Carbon number 6 coming in from the left, or 1, 2. Carbon number 2 coming from the right. So this is oct2ene. No branches. There's your answer. Oct2ene, or 2-octene. If you want to do it that way, that's fine. And then down here, this one, what do we notice? 1, 2, 3, 4, 5, 6, 7. Now we can't take that as a main chain because it doesn't contain the double bond. So the double bond main chain is this way here. 1, 2, 3, 4, 5, 6, 7. That's going to be hept. There's a double bond present, so it's heptene. Where is it? Carbon 1, 2, 3, 4, or carbon 1, 2, 3? Well, definitely carbon 3, so we're going to be coming in from this angle. So it's hept3ene. And we notice a branch, and the branch is methyl, because it's only 1 carbon, and it's on carbon number 1, 2, 3, 4, 5. So this is 5-methyl hept3ene, or 5-methyl 3-heptene. That's the alternative way to write that one. Okay, I want you to draw the structure of each of these. Now again, pause this video, draw these structures, and then come back to me when you have it done. Okay, structure of the first one, and this time we're going to work backwards. This is pent. 1, 2, 3, 4, 5. It's a 2-ene, so that means the double bonds after the second carbon. So let's go this way. 1, 2, double bond in there. Fine. So that's that part taken care of. And then on the third one, there's a methyl group. 1, 2, 3. There's a methyl group. There it is. It's a branch with 1 carbon. That's the structure. Don't have to draw on the hydrogens. No need. That's fine. And then cyclohexene. Now, this is a lovely word because cyclo means, and I did this in class, I think, just before we broke up. Cyclo means around in a circle. So this is 6 carbons around in a circle with a double bond somewhere. So 1, 2, 3, 4, 5, 6. There it is. Now where's my double bond? Doesn't matter. We don't know where carbon number 1 here is, so we can put it anywhere. Let's just put it there, and that is cyclohexene. It's that easy. Okay, again, draw these two, please. Pause. Off you go. Come back with your answers. Okay, so now that you've drawn this, again, hexene, 6. 1, 2, 3, 4, 5, 6. Hexene, 1 hexene means the double bonds after the first carbon, can also be called hex-1ene, that's fine. And then on the second one, you've got an ethyl branch. So on the second carbon, you've got 2 carbons coming down like that. That's that one. And cyclopentene, what does that mean? 1, 2, 3, 4, 5, around in a circle, or in a pentagon as this would be here. Where do I put the double bond? Wherever the hell you want. There. Grand. That's it. Done. So what I'm going to do now is I'm going to leave you with these. I'm going to let you answer these questions yourselves. You can send the answers back into me if you're not too sure what they are. You can pause the video now and you can do it, and then we're going to come back with the answers. Okay, so you've taken time to do these. Let's take a look at question 1. Briefly identify the important distinctions between a saturated hydrocarbon and an unsaturated hydrocarbon. That just wants to make sure you understand the difference between the two words. Saturated means that the carbons are all singly bonded and they have a maximum number of bonds allocated to them. Unsaturated means that there are some carbons that are doubly bonded or triply bonded, meaning that there are electrons present in a multiple bond that could, if the need arises, be distributed to engage with further bonding, allowing other atoms to add on. So saturated simply means single bonds between the carbons. Unsaturated means there might be a double bond, or indeed, as we'll see in the next set of slides, there could be a triple bond. Briefly identify, question 2, the important distinction between an alkene and an alkane. Now, first of all, obvious difference, the spelling. Ene means that this has a double bond, so therefore it's unsaturated. This one here has all single bonds, therefore it's saturated. Okay, and they would be the biggest differences between those two molecules. Obviously then we need to remember that what's important here is the position of the double bond. Don't have to worry about that here. And then obviously the branches that are added on between them. Another distinction would be the ratio of carbons to hydrogens. Here with the alkane, Cn H2n plus 2, but here the ratio is Cn H2n. Okay, classify each compound as saturated or unsaturated and identify each as an alkane, alkene or alkyne. Okay, let's take a look at the first one. Do you notice no presence of a double or triple bond, so therefore this is most definitely saturated. And it is a saturated what? Alkane. Good. Second one, stuck over here. Notice we have a triple bond. This is an alkyne. YNE, and because it has a triple bond, that means it is unsaturated. And lastly, part C, you have again a double bond, so this is an alkene, and because of the fact it's a double bond, again it is unsaturated. Okay. And those questions then will help you to understand the major differences between the alkenes, the alkanes, the alkynes, and the structure of those molecules. Now,